this video, we will look at a matrix inversion example for a matrix of size 3 by 3. So we are going to have 3 rows and 3 columns, and we are going to consider a square matrix to do an inversion operation. So let's first try to answer the question whether a matrix is invertible or not, and how we can find that out. A matrix A of size n by n, so we are considering square matrices, is invertible if there exists another matrix B of the same size n by n, such that matrix A multiplied by B equals BA, which equals identity matrix of size n. So identity n means it has n rows and n columns, and all ones in the diagonal, all the rest of the elements are 0. So if we have a matrix B that exists, then A is considered to be invertible. Now, invertibility, it's also referred to as non-singular matrix or non-degenerate matrix. On the other hand, if a matrix is non-invertible, it is also called a singular matrix or degenerate matrix. Now, a simple check that we can run to find if A is invertible or not is by evaluating the determinant of that matrix. So if that determinant equals 0, then we are going to call that non-invertible or singular or degenerate. But if it is not equal to 0, then it will be invertible. So this is a quick check for the determinant to see if it is invertible or not. Now let's consider a matrix Z, and we'll try to find Z inverse. I'm considering a matrix Z with 3 rows and 3 columns, and the elements in matrix Z are small a, b, c all the way to small I. Now to find Z inverse, we are going to use the same formula as we have used before, which is 1 over determinant of Z multiplied by adjugate of Z or adjoint of Z. Determinant of Z remains as is, but in this case the adjugate of Z is a matrix, another 3 by 3 matrix, which has some elements that are written up in red, and they're also capitalized, which means their values need to be determined, and it's a transpose. So that T over there stands for transpose operation, and we'll talk about what transpose means in just a bit. But adjugate of Z is essentially a transpose of matrix of cofactors, and cofactors are A, B, C, and so on. So first we need to find the cofactors, and then transpose that matrix to find the adjugate of Z, and we'll also have to find the determinant. So there are several steps that need to go into finding the inverse of a 3 by 3 matrix. So once we have this laid out, let's try to see if we can find the cofactors and essentially write their relationships to the original matrix Z. So first I have Z over here, similar to the previous slide, A, B, C all the way to I, and these small letters are being used to suggest the element value in Z, and capital letters are being used to denote the cofactors corresponding to the letters, corresponding to the elements. So if we need to find the adjugate of Z or adjoint of Z, we need to find the transpose of the matrix of cofactors. And to find that, we only need to find the cofactors A, B, and so on up till capital I. Now, the first thing that I would like to point out over here is the sign of the cofactors. So for example, there is a pattern. A is positive, B is negative, C is positive, D is negative, plus, minus, plus, minus, plus. So essentially it has a pattern which I can write as this, which is superimposed on some calculation. So once we have noticed that, I'm going to next try to find the value of the cofactor and how that relates to the matrix Z. So for example, if I wanted to find out cofactor capital A, then I would go to its corresponding row and column, and I would essentially hide row 1 column 1 because A is in row 1 column 1. And then I'm going to find capital A as the determinant of all the other elements or the submatrix. So in this case, the submatrix is essentially EFHI, and the determinant of that is simply E times I minus F times H, which is written up over here. And we do the same thing 9 other times to find all the cofactors. So for example, let's pick another one. Let's go to say B and say we wanted to find the cofactor of B. We go to the element corresponding to that row and column, and we are going to essentially hide this row and hide this column, and we'll be left with a submatrix DFGI, and we are going to essentially find the determinant of that submatrix to be D times I minus G times F, which gives us cofactor B. But also remember that we have superimposed a negative sign onto that. Similarly, we do that for C. If you want to do that for C, just go to the corresponding element, hide row, column, and then find the determinant of the submatrix, which is in this case going to give us DH minus GE right there, and of course the plus sign carries over here. Now I hope that you can once you see this pattern, I hope you can write all the other cofactors, but don't forget the signs that go along with those cofactors. Now once you have that matrix of cofactors, we then transpose that matrix, so switch all the rows to columns and columns to rows, and we would get our adjugate of Z. Determinant of Z is pretty straightforward. We could do this with respect to any row or any column. In this case, we are doing it with respect to the first row. So we would take the elements A, B, C in Z and just multiply them by their respective cofactors, capital A, capital B, capital C, and add those results up. We are going to get our determinant. And then once we have the determinant and the adjugate, we just plug it into this equation that was given earlier, 1 divided by the determinant multiplied by the adjugate of Z, and we'll have our Z inverse. All right, let's go over an example to see how this works. We are given a matrix Z, 3 rows and 3 columns, and we are asked to find Z inverse. So we'll first try to find the cofactors. So let's say A. Well, I'm using the same place locations, so A, B, C, and so on, all the way to I. So when I say capital A, I just mean the cofactor corresponding to the first row, first column element. All right, so what is A? I'm going to hide, and then I'm left with a submatrix 1, -1, 2, -2, and the determinant of that is going to be 1 times -2 minus -1 times 2. So that gives me -2 plus 2 is 0. Let's move on to the next element. So So for B, we are going to have hide, hide, and then we are going to have that negative sign for because of that, and then we find the determinant 2 times negative 2 minus negative 1 times 1, so that will give us negative I've got negative 4 plus 1, so that should be 3. And similarly we can find out all the other cofactors. Let me try to find C here. So C is going to be positive 4 minus 1, so that should give me 3 for C. D, which is for that element, is negative hide and then negative 2 minus 0, so that should be 2. E, which is for that element, hide, hide, and I'm left with for E it is going to be positive and negative 1 times negative 2, so that's 2 minus 0, so E is also 2. And then F, which is for that element, hide, hide, I've got negative 1 and this is minus, so negative 1 multiplied by 2 minus 1 times 1, so 1, gives us negative 2, negative 1, so negative 3. Alright, just negative 3, positive 3. C, D, E, F. Alright, for the next element we are going to hide for G, so cofactor for that element, hide, hide, we are going to have this is positive now, 1 times negative 1 minus 0, so that's just minus 1, so we are going to get negative 1 for G. H, erase everything else. H is for this element, hide column, hide row, and then negative sign superimposed. We are going to have negative 1, so 1 minus 0, so H is also negative 1. And then the last one, I, is for that element, hide, hide, positive negative 1, negative 2, so that should be negative 3. Alright, I hope you find it easy now to find the cofactors, and let's go to the next step. So the first thing I'll do is I'll erase all of this because I've already found them out, and then I'm going to essentially write the adjugate of Z. So I have adjugate of Z as a matrix of cofactors, and at the end I also need to transpose this matrix. Now I've already found the cofactors. Those were 0, 3, 3, 2, 2, 3, and negative 1, and negative 3. Now we still need to do the transpose. To find the transpose, we would have all the rows switched with all the columns. So for example, in this matrix over here, the first column is 0, 2, negative 1. That would essentially be our first row after we do the transpose. is essentially switching all the rows with columns. So first column is 0, 2, 1, that becomes the first row, 0, 2, 1. Second column is 3, 2, negative 1, that becomes the second column, second row. 3, 3, negative 3 becomes my third row. So I've already done the transpose now. Next I need to find the determinant. Determinant of Z is A times A plus B times B plus C times C. We already know the value of the elements. A would be negative 1 multiplied by the cofactor capital A, which we found to be 0, plus B is 1 multiplied by cofactor B, which we found to be 3, plus C is 0, so I don't care about that. So that gives me C, 3. Right, because this goes away, we just have 3. So we have found determinant, we have found the adjugate of Z. We just need to put these two together, and let me write down the answer right here. The Z inverse would essentially be 1 over 3, and the adjugate of Z is 0, 2, negative 1, 3, 2, negative 1, 3, 3, negative 3. Now what you could also do here is bring this factor of 1/3 into the matrix and divide all the 9 elements by 3 to simplify it a step further. We are just going to leave it over here as is. Now suppose you have done all this exercise, you have essentially found out your Z inverse, and you want to check because as you can imagine, there's a very good possibility of a mathematical error after doing all these calculations. So if you wanted to check, you essentially need to use the definition of invertibility and check it. So how do you check? Well, if you have the inverse in Z, if you multiply this with our original matrix Z, it should give you the identity matrix. So you could use MATLAB or hand calculations of matrix multiplication to take Z inverse, which we have done over here, and take the original matrix Z, which we are essentially given, and the matrix 3 by 3 matrix multiplication video should walk you through how to multiply two matrices, and if the result comes out to be an identity matrix of size 3 by 3, then we know that we have done all the mathematical calculations correctly. All right, I hope this was helpful.